EVM or Ethereum Virtual Machine. If you have heard this term before, you are probably a blockchain developer or have been in this space for a while. You and I understand EVM improvement is important to improve the portability of software as well as to make sure applications are separated from each other and also from their host. Today we are going to talk about upcoming EVM changes with Team Epsilon. Welcome to the 70th episode of PEEPanEIP, an educational video series where we discuss an Ethereum improvement proposal, upcoming upgrades, and the basics of Ethereum blockchain. I'm Pooja Ranjan, and today we are going to discuss Shanghai upgrade CFI proposals, EIP-3670 EOF Code Validation, EIP-3540 EVM Object Format version 1, with co-authors Alex Perigzazzi, Andrei, Maiboroda, Pavel Bailika. Thank you for joining us.
Thank you, glad to be here.
Team Epsilon, formerly known as Team EVM, are long-time contributors to EVM upgrades. They have been on our show multiple times to discuss different proposals. EIP-3541, which was deployed with the London upgrade, EIP-3855 and EIP-3860, which are expected to be going live with the Shanghai upgrade. So if you missed watching a recording for any of these, check out our playlist for respective upgrade. Welcome again, team. Super excited to have you here to learn about upcoming changes. I assume you guys have a lot of talking to do. So without further ado, let's PEEPan.
Okay, I will be doing a presentation, maybe a couple of words of introduction. My name is Andrei and I work with Epsilon team. I'm working in general on Ethereum since late 2016. I was maintaining C++ client of Ethereum originally, and after that transitioned to working with EWASM team, which is currently known as Epsilon, and we are focusing on EVM related research and development since then. And yeah, let me share my screen now. All right. I would like to start first with explaining what's the relation between these different EIPs that we have by now. We have a series of EVM object format related EIPs. First one of them was EIP-3541. It is currently already deployed in the London upgrade, and it was kind of a preparatory EIP that made it possible to make a full proposal for entire EVM object format spec. And now we have these EIP-3540 and 3670, which are considered for inclusion for Shanghai, and we will be focusing on them in these slides. But we also have a couple of proposals that build on top of this base, which is defined in these two EIPs. So maybe a bit more, I'll mention them in the end, but these are like new features that can be built on top of EVM object format. And yeah, but these two EIPs that we have accepted for Shanghai, I should also clarify the relation between them. So 3670 technically requires 3540. It does not, it's not possible to deploy it without it, but in fact, we see these two as kind of a single EOF proposal. So we are strongly in favor of activating them together in one upgrade in Shanghai. And yeah, this will provide some benefits. And yeah, 3670 is kind of an extension to one part of 3540, and they are split mostly for convenience of reviewing them by core devs. And yeah, that's why we are presenting them together, and they should be thought of as one single proposal, I think. So first, let's touch on the motivation for both of these EIPs and for EOF in general. So one way to look at it is to think that there is a multitude of various issues, you could say, with EVM design, or some weird edge cases in design decisions made that are hard to change with the live network. For example, the way we introduce new instructions in the EVM is it involves some kind of a risk every time, because if any of the old already deployed contracts on chain has the value of the new opcode, and it relies on the fact that this opcode is undefined, and that is, it will abort execution in case execution reaches this byte. And in case we want to define this as a new opcode, it means that some old contracts might change their behavior, and then they might break. So this is highly undesirable, and this risk is always around. It's not a huge risk. We don't think this ever happened, but it's not an ideal design, and we would like to improve this situation. And another more important and a bigger problem is similar, but it's about deprecating some of the instructions that are existing right now in EVM and are due to deprecation for various reasons. And this is also not an easy task, because the problem is similar. Some currently existing contracts do use these opcodes. Yeah, example of these opcodes is SELFDESTRUCT, for example. People want to get rid of it, but some contracts do use them. And in case we just define it as not defined anymore, those contracts will break. And we would like to avoid that. And EOF finds a way to address this, at least partially. Another kind of a problem with EVM is the way that how jump instructions work currently. So jump and jump I instructions require that target to be a special byte value, which is called jump dest opcode. And this rule seems simple, but there is a weird edge case to that. In case this jump dest byte is inside push data, there is bytes immediately following one of the push instructions. Those are bytes that push instructions pushes on stack. In case jump dest is inside this data, it is not a valid jump destination, and attempt to jump there must fail. And this leads to a complication, because to make this possible, client implementations need to do some kind of analysis before every execution. It's called jump dest analysis. And this also should better be improved, and EOF provides a way towards getting rid of these kind of jumps. And and final problem mentioned here is that it is quite common for contracts to have some portions of the bytecode be not really a code to be executed, but some data. Like, as an example, Solidity compiler puts metadata in the very end of each bytecode, and this is not meant to be executed. It is just data, and it is fine for EVM interpreter itself, but for various tooling or layer 2 solutions, it's difficult or can be infeasible to find these data sections, and it might be important for them because they might want to do some analysis, some static analysis on the code part only. And so this is complicated currently. This is one of the well-known problems with EVM. There were some proposals trying to address these, introducing some way to mark these data section. And EOF also is trying to address it in some way. Also, it provides a way to do exactly that. Or another way to look at motivation is to think that versioning mechanism is something that is highly desired in EVM because it would actually solve these problems that I just mentioned. It would be easier to introduce new features like new opcodes, or deprecate some currently existing opcodes without disruption to already deployed contracts. Or it would provide extensibility, in other words. This is also was approached several times by several proposals. Many of them tried to add a version into the account structure, which is problematic because it makes it activating such change kind of complicated. It would require the change to the structure of the entire state tree, and this would probably need some migration procedure. So EOF tries to approach it in a different way by putting the version inside the bytecode, and yeah, I'll show this in more details a bit later. And another important part of the motivation is we would like to introduce this validation at deploy time, meaning that any contract when it is being deployed will first go through this validation procedure, and in case it's invalid, it will be rejected. And this provides very useful properties that we think in general, like not allowing invalid code on chain is beneficial for various reasons. Yeah, this is one important part of motivation behind EOF. And I'll get now into the specification as outlined in EIP-3540. I would say the specification consists of several distinct parts there. The first one is just general container specification. Container is a term introduced in the EIP to disambiguate from the older term code, so meaning that account will be associated with an entire container and code can be only a part of this. That's why a new term like this was needed. And yeah, this is a general description of the binary format for the container. It is general in the sense that it should apply to any EOF version currently proposed or any future version. Yeah, and it looks like this here on the picture. More specifically, it starts with magic sequence. These are 2 bytes EF00, and these are, yeah, this is a special combination that was chosen specifically in such a way to guarantee that no other contracts with this prefix already exist on chain as of now, and thanks also to this already mentioned EIP-3541. It is forbidden to deploy other contracts since London, so this allows us to make sure that only valid contracts will end up deployed on chain. And yeah, following it, there is 1 byte for a version. We define version numbers starting from 1 to FF. We leave 0 value just in case some tools would like to use 0 to mean legacy code. And following that, container basically may consist of arbitrary number of sections. There is a description of each section first, showing its kind as a 1 byte value and its size as 2 byte value. And then following that, there are contents of all the sections. And next to that, the spec defines a number of rules to validate this binary format. These are kind of common sense rules. I will not read them out, like things like sections should not be empty, must not be empty. And the next part of the spec, it defines the first version for EOF. So this further restricts this validation. On top of container being well formed, there is this specific thing that we call the first version of EOF, and specifically it means EOF version 1 has 1 obligatory code section and 1 optional data section. In other words, any EOF version 1 valid contract will have either 1 code section and 1 code section only, or a code section plus a data section. And the implication here to note is that data-only contracts will not be allowed. In case you would want to deploy only data, you would still need to have at least 1 byte long code section. Yeah, and here I'll illustrate all these rules in a simple example of how EOF code could look like. So above you see legacy code as it exists now. This is just a sequence of opcodes without having any particular structure. And EOF code can be seen as having these 3 parts. First part is a header defining all sections. Then the code section follows it. And finally, there is a data section. And some more details like, yeah, it starts with this magic sequence, then 1 byte for a version. Then this describes the first section, which has the kind number 1, which means code, and B is its size. Then another section with the kind 2, which means data section, and its size is 4. Then this 0 just terminates this entire header part. Then the code section contains just a regular sequence of opcodes as the bytecode, legacy bytecode does now. This is nothing special here. And finally, we have a data section. In this particular case, it is also a sequence of opcodes because this entire container is an init code in this case, and it returns this data in the end, and this data will be deployed on chain as a code of new contract. So in other words, these are also sequence of opcodes, but they are treated just as data. They are never executed for this contract. Yeah, and here I'd like to explain what EIP-3670 is about, because this is exactly the place where it extends EIP-3540. It extends the validation procedure. So on top of validating the format of the contract, that it is well formed according to container spec, and that it is well formed for EOF version 1, having all necessary sections. There is additional procedure which for validation, which is applied to a code section only. And this has just two rather simple rules. The first one, we forbid to deploy any bytes that are not a valid opcode as of now. Yeah, any attempt to deploy an undefined opcode would result in a failure. And motivation for this is this makes implementation a bit simpler in the part where to determine whether a specific byte value is defined opcode or not, you would need, with this rule in place, you would need only EOF version, and otherwise you would also need network upgrade version, probably fork version or something. And yeah, another motivation is this: with this rule in place, it becomes easier to introduce new opcodes in the future without bumping EOF version. We see this as a useful property. And a second rule or validation check is we require the code section to end with one of the instructions terminating execution, like stop, return, revert, self-destruct to, and invalid opcode. And yeah, this provides a number of benefits. One of them is this makes implementation more efficient in a way that it does not need to check on every iteration that we reach the end of the code, and it can just assume that there is a terminating instruction somewhere in the end. And another very useful and important implication of this is push instructions at the very end of the code, which don't have enough data bytes, are not allowed this way, because push cannot be a final instruction at all. And this is different from the situation in the current EVM, where truncated push data is implicitly padded with 0 bytes. And this, yeah, we see this as a bit of a complication for implementations too. It would be better not to have this edge case as well. And yeah, so we think it's beneficial to not allow this at all. And this is what this EIP provides. And that's mostly it for what there is for EIP-3670 spec. One thing to note is it's possible to deprecate some of the opcodes that we think are due for deprecation, at least for the future EOF contracts. It's like as easy as excluding them from the list of the defined ones, and according to the validation procedure of EIP-3670, any contract with these opcodes will be rejected. And yeah, we generally think it's a good idea. We're in favor of doing it. It's not currently part of the EIP, but I think we want some more feedback regarding whether it should be the same EIP-3670 or we should make another one for this. And yeah, but in general, we're in favor. And yeah, another important thing about EIP-3670 is related to security considerations. So this new validation procedure for code section, it introduces some overhead, because to perform these checks, you need to do one pass over the code section. And yeah, and it must be accounted for in the gas charges for creation of the new contracts. And also the thing to note here is that this happens in two stages, you could say. First, the init code is before being executed is being validated with all the rules for EOF. And when init code finishes execution and returns the code to be deployed, that code must also be validated, and it must be valid, otherwise it is not allowed to be deployed. So there are two stages to this overhead, two parts of it. And for the deployed code, we already pay 200 gas per each deployed byte, and that is quite high price. It accounts for the storage for the new contract, and we think that it's not reasonable to increase it like just a bit for one gas or something. We think it covers enough to cover the validation of the deployed code as well. But for init code, there is no such charge currently, and but this EIP-3860 is related to this, and one of the motivations for that EIP is also to cover this case related to EOF. It has other benefits too, and it's useful by itself. But we also in favor very much of activating it together with EOF proposals because it will make it more secure to have this validation in place. And getting back to the specification of both EIPs, so one important part is the changes to the rules of how a contract is created. Yeah, this is the same thing that as I just mentioned. The validation is added to validate both init code and deployed code. But also we do not disallow in these EIPs deploying the legacy code yet. We think it's still useful to have some transition period when it's allowed to use legacy code and deploy legacy code still. So this means that init code can be either EOF or legacy code, and the implementations should check it by the prefix. In case the init code or code has EOF prefix, it means that the code declares itself as being EOF, and then it must go through validation procedure. In case it ends up invalid, then the entire creation fails. For creation transaction, it means just aborting the creation and aborting the entire transaction. Transaction fails in this case. And for creating two instructions, that means execution of them ends with the 0 result on stack. This is similar to other creation errors for these opcodes. And there are some also some details in the EIP-3670 regarding what gas is deducted in all of these cases. This is important for implementations to make this work correctly, and yeah, client implementers should should read that for sure. And another thing to note is that so init code and deployed code are independent in a way that both of them can be either EOF or legacy code. So there are these 4 combinations possible. And EOF init code deploying EOF code, we see this as kind of an ideal situation, ideal future for EVM when everything will be EOF code. Yeah, we do not disallow, as I said, deploying legacy code from legacy init code. This is just a usual normal legacy situation. Legacy init code deploying EOF code is also can be useful, we think, for this transition period. But this striked out option, EOF init code deploying legacy code, we don't really see much sense in allowing this. So this is not part of the spec currently, but we are planning to add this change. We are planning to forbid this. This is not. It should not be allowed, we think. So there are these 3 combinations left, really. And finally, the spec this is the final part of the spec of EIP-3540. There are some rather minor changes to the execution rules. So jump instructions, they still require a jump test opcode to be a target of the jump, but this jump test must be inside code section only. In other words, you are not allowed to jump into data section. Yeah, that would result in a in execution exception in abort. PC instruction returns an offset relative to code section start. In other words, it starts with 0 and grows from there. And code copy and Xcode copy opcodes, on the other hand, use absolute offsets in the entire container, and that is useful to make it possible to copy from the data section if needed. Yeah, so that's all I wanted to tell about these two EIPs. As I mentioned, we have these other proposals which are using 3540 and 3670 as a base and build on top of it. One of them is 4200 static relative jumps. These are new instructions for jumps, basically, that have their destination statically known. They are taking it from immediate argument in the bytecode as opposed to taking it from stack as current jumps do. And this is beneficial for a number of reasons. This can be seen as a step towards getting rid of dynamic jumps completely, which is desirable for some reasons. And yeah, another step is this second EIP-3750, which proposes a new subroutine mechanism where we define multiple code sections possible in the EOF, and each code section represents the code for a subroutine, and a couple of opcodes there to call a subroutine and return from subroutine or a function. And the final EIP mentioned here, 3779, is a work of Greg Colvin, and we think this is also very interesting direction to explore, and it proposes some advanced procedure to validate the code section, which would provide much stronger guarantees, like, for example, it can prove that code during execution cannot underflow stack, for example, and that it is very beneficial to know that, because then we can not do these checks during running of the contract, and this would make the implementation of EVM simpler and more efficient. Yeah, there are other ideas too, also based on EOF proposals, but these are, yeah, we find these important and interesting. And yeah, that's all I wanted actually to present. We have this meta spec kind of a document. It has all the links about to all the write-ups about EOF. So if you want to learn more, so check this link out. Yeah, that's all I had. Thank you.
Thank you. Thank you for this great presentation, Andrei. I'm sure this is helpful. It brilliantly explained the motivation behind these proposed changes to EVM. Some EIP editors suggested that it is always good to have small EIPs instead of one big and complicated one. So I think it is good that we are having all these EIPs, smaller EIPs, precise and well documented. While you have covered most of the questions, the biggest question, why, I have a couple more to go on these proposals. If it's fine, I can just pick up a couple of questions with you.
Sure.
Okay, the first one is related to EIP-3540. What advantages do you think was there in deploying 3541 with the London upgrade, and why it could not have been deployed together, just like we are deploying these two EIPs together here?
Yeah, that's a good question. I can try to explain this. So it would not be possible to deploy them together because if we would try that and we publish the proposal to that would say that codes starting with EF are going to be EOF codes, then someone could just take this prefix and deploy such contract immediately, because these rules are not in effect yet. The upgrade didn't happen, and then it would break our highly desired property of all the contracts deployed on chain being validated, going through that they went through validation and are proved to be valid. So it would be very easy to break this invariant, yeah, then we don't get this, and this is something very different from what we want to achieve. And by deploying this in this two upgrade mechanism, we first forbid to deploy contracts starting with EF byte, and then at this moment, some people can still deploy some contracts like this, and there were actually 3 of them, I think, deployed on the mainnet since between we announced this EIP and between London upgrade, but when it was forbidden. And after that, after London upgrade, we analyzed this entire chain and found these 3 contracts, and have chosen this prefix that still allows us to say that all future EOF contracts will be only those that will be deployed after Shanghai.
That's a very good point. These reserved bytecodes, those are introduced by 3541. Was it in any way affecting the present EVM working?
So I don't think it affected EVM in any practically important way. So it strictly speaking, it does affect the consensus rules. Some of the things that could be deployed before were not possible to deploy after London, and is not possible now. So some rules did change, but I don't think this affected anyone. We haven't heard of anyone complaining. No, this is just there should be no reason to be affected by this. Really, it's a minor kind of a change, but with important implications.
Yeah, if I can add to that, I mean, we pick EF byte as a kind of first one of the magic sequence, and we knew that nobody actually deployed contracts for the whole history of Ethereum with starting with this byte. And the only 3 examples that happened would actually related to this EIP we proposed, and that was the main indicator. But like formally, yeah, that can be a case that some system of smart contracts that wants to deploy some data, because this never can be executed, can be broken by that. But so far there are no evidence that this ever happened.
That is good. Thank you for sharing. All right. My next question is related to EIP-3670 and also self-destruct. So as per the proposal, 3670 introduces codes validation at contract creation, like when it is being deployed for EF format, that is 3540 contracts. It defines what to keep, what to reject, right? And in the discussion tool link, I found that self-destruct opcodes are proposed to be rejected. Even Andrei mentioned that the team are in favor of deprecating self-destruct. If one of you could take a little bit time to maybe explain self-destruct, why it was put in the first place, and why do you think it is better to reject or deprecate?
Yes, who wants to take this one?
So I can say a few words, and you can correct me afterwards. Like one of the, so basically it was put in as a way to conserve state size, to reduce state size, because basically their operations like S-store or even contract creation where one can insert more data into the state. And even though with store, it is possible to zero out the value of a given storage slot, it is not really possible to entirely remove a storage slot because it still kind of exists. And the self-destruct instruction is the way to get rid of not only the storage slots, but also the code of a given account. And the idea was that this would be used wisely, and it would be a good way to conserve the state size, because contracts would be just removed once they're not needed. However, this process is rather complicated and it has been misused. And the biggest risk right now, which clients face, is that when you self-destruct an account, it is kind of an unbounded operation, because all of the storage slots have to be also removed. And there can be many storage items of a given account. So it is not like a single step operation, just removing the code and like deleting the account. It may be a series of operations, depending on how the client has been built, to remove all the data related to the account. So this has been one of the motivations why people want to get rid of self-destruct in general. But also other proposals, like different tree designs for the state, they would also benefit from not having this operation. So I guess that's like in I guess why people want to get rid of it.
Yeah, so those like, I think there's like quite long discussion about how to deprecate self-destruct and what way to do it, like how to do it actually. But I think in the context of EOF, what is important that the EOF doesn't affect how self-destruct works in the legacy code. So it will work as it was, or it will be modified, but it's kind of the separate set of proposals how to do that. But EOF kind of starts, let's say, like with blank page of how we want to see like future EVM bytecode. And here we can allow to kind of discourage some features that exist in old EVM. And I think that's one of the like strong arguments for that, because self-destruct causes so much trouble around it. So maybe it's good to start this new EVM, let's say, version that actually doesn't have it included. So it will continue for the old like contract subsystems. It will continue to work as it was, or it will be modified. It depends. But at least here we can start without it. And one more nice thing about EOF is that because of this forward compatibility properties, we can always add it back if that's needed, or like add modified version. But it's rather better to start without it if there's some controversy about how this feature should work. And we can have some time to actually decide, yeah, what is the ideal version of it.
Well, thank you for explaining that. I know this was not directly related to the proposal, but because this is also a very important topic, and it's always good to have as much as information available on this topic. And now that it is being proposed that should not approve that contract for self-destruct, so it's good to know.
Maybe like one more word. I think that's kind of we kind of considered from the beginning, but like we wasn't like super committed to that. But we had some discussions recently, and I think current sentiment is to actually drop the self-destruct, and also the CALLCODE instruction that was deprecated and replaced with delegate call as a kind of fixed version of it. So I think that hasn't materialized fully in the specification yet, but seems that will be more as the direction we want to go.
So I have one more question related to testing part of all these proposals. We can see test cases for contract creation, valid code, invalid codes. How far along would the team consider that you have reached for testing proposal 3670 or 3540 or all these proposals related to EVM that team is proposing for the next upgrade?
Yeah, I can answer this. So from the point of view of consensus tests, we have already comprehensive set of tests for 3540 at least. It is in an open PR in the tests repo and under review. We use, by the way, our implementation in Go Ethereum to generate the tests, and we also are aware of another team, Ethereum JS team, that already implemented EOF proposals and used these tests successfully, and and other clients are welcome to do the same. And for 3670, I would also say it's quite far. We have a set of tests. I think they are quite complete, and we will open a PR on test repo soon as well. Yes.
That's good to know. One last question, maybe related one. Where can people follow the progress on these proposals, or if they would like to participate in, sending some suggestion and having some questions around?
Well, the best place for discussion is discussion to links, which link to Ethereum Magicians forums. Yeah, otherwise we publish updates usually on HackMD, and we have a Twitter account for the team, which can also announce if there are some significant updates.
Do we have any specific channel to discuss all these proposals, maybe in ETH R&D or somewhere else, or teams?
On ETH R&D, we follow EVM channel at least, so it is fine to post questions or suggestions there as well. Yes.
That's good. Thank you. I think I am done with all these questions. Anything else anyone would like to share with our viewers related to the proposal or in general? I hope we are good to wrap up. Hopefully, information shared today is helpful for the developers building projects on EVM. Thank you so much, Andrei, Alex, and Pavel, for taking out time and talking about these EVM proposals. On this note, thanks to all our YouTube viewers for watching. If you have any question, comment, concern, join the discussion on the discussion tool link provided in the description. If you have a suggestion on which EIP would you like to learn more about, let us know in the comment or share on the ETH Discord. Subscribe to ECH YouTube channel if you haven't done it already. See you next time with another interesting proposal. Till then, keep watching, keep sharing your love with Ethereum Cat Herders.